Hello, look at this, 2 hands. Wasn't gonna make a video for you for today, but I was so excited about my new present that I thought I had to try it out. So y'all can thank Henry for this. Still haven't mastered it yet, as you can see. I don't know how. Well, like I said, still working out the kinks, but not bad. Let's see if I can do this. So we're going to move into functions now. So that leads me to your first homework problem, which is tell me what a function is. And just your own words. I don't want the book definition or a Google definition. Tell me what you think a function is. And if you don't know, then you say you don't know. But so that's one. The other thing you're going to have to do is identify some graphs, and it's going to be multiple choice with functions. Well, there's going to be a graph, picture of a graph, and then a bunch of equations, and it's just matching. So, well, not multiple choice, I guess matching would be the proper terminology. So I really don't need to show you anything for that because I think you should know them all from last year. There's one individual who might not, because I don't know that they teach that in Chilean. But anyway, so you're going to have to match some graphs with some equations. I'm not going to talk about that. You're going to have to evaluate some functions for different values. For example, that's just like if you had g of x equals, try to pick a hard one, like the absolute value of x divided by x, and then you were told to find g of -3. Hopefully you remember that just means plug -3 in for the independent variable. So in this case you would just go absolute value of -3 divided by -3. Absolute value of -3 is 3 over -3, which would be -1. And that just means when x is -3 for that equation, y would be -1. And of course, we're going to start connecting that to graphs later. But for now, you're just going to plug stuff in. If you get something like g of -x, all you're doing is plugging whatever's in here in for x. So that would be the absolute value of -x divided by -x. Because if I plug that in for both of those, that's what I get. Well, the absolute value of -x is always going to be x. And then -x is just -x. And again, I get -1. Weird. So you can simplify it after you plug in the x usually. Or you could have, let's see, I'll just do one of the ones out of the book here. Like this one. Oh no, that's one of your homework problems. So let's go, like there's one that's like f of y equals, where'd it go? 3 minus the square root of y, and then it asks you to find f of 4x squared. Well, so you just plug that in for that variable and simplify it. So it'd be 3, that was supposed to be minus the square root of, and I plug that in there, so I'd have 4x squared. Simplify as much as possible. We know the square root of 4 is 2, square root of x squared is x, so it's just 3 minus 2x, and that would be it. Just simplify it as much as possible. Alright, I'm back. Here we go. That was like instantaneous for you, but that was about 10 minutes ago, so well, I don't even remember what I was talking about. Plugging in stuff, simplify it as much as possible. That's it. Okay, last thing, domain. Hopefully you know all possible x values for a function. And looking at it graphically is pretty easy because you just look at where the line goes. Like, oh, hey, look at there's a graph. The domain of that, if it's got arrows, would be all real numbers because it hits everything. Or if it didn't have arrows, it would just only from 0 to 120, right? Or if I was like, what's the domain of this piece? You'd be like, oh, from 50 to 70. That's domain on a graph. But for functions, let's see, I think you guys think Stanbury should have taught you this. You just, like, if you have f of x equals x squared plus x minus 4, that should be a no-brainer. Either picture it graphically, know that it's a parabola, and all parabolas go left forever and right forever, so the domain's all real numbers. Or basically what you want to look for when you're doing domain on these is the only thing that's going to restrict the domain, or the only thing that's going to make it be not all real numbers, would be if you've got a square root in there and an x underneath, because now we can't have negatives under a square root. So like the square root of x, the reason the graph looks like that is because, hey, for positive numbers, yeah, I plug in numbers for x, I get values for y, it slowly goes up. But if I try to plug in negative numbers, it doesn't work. So there's nothing over there. So the domain of that would just be x is greater than or equal to 0. The only other thing you have to look for is fractions. If you've got some stuff up here and then you have an x on the bottom, x can't be 0. You can't divide by 0. So that's why the graph of that, and I think we just talked about this the other day. When x equals 0, there's an asymptote there. So again, but you're not going to have graphs, you're just going to have equations. So all you have to do is, so like if you have, here's a function, this is number 55 out of the book, it's g of y equals the square root of y minus 10. You should know, hey, I can't have a negative under a square root. And so you can either just logically think through it and think what y could be. And it's not just y is greater than or equal to 0. That's not true, because whatever y is, you're going to subtract 10 first. So if y is 1, 1 minus 10 is negative 9. It doesn't work. So there's, the easiest way to do it is just go, well, if you're a thinker, think through it. But if not, just go, hey, I know this part under here has to be 0 or bigger. So you take it and you create an inequality. And since we just learned how to solve inequalities, that should be simple now. Add 10 to both sides. Hey, the domain is y is greater than or equal to 20. That's I was like, that's not right. Why did I put it greater than or equal to 10? No, it's greater than or equal to 0. This has to be positive or 0 under here. Add 10. Y is greater than or equal to 10. Well, there we go. I just lost a few subscribers because of that. But anyway, so another example would be like, I always like this one, where it's like f of x equals 1 over the square root of x plus 2. Something like that. And tell me the domain. I have no idea what the graph looks like, so I just have to think through it. What's going to restrict my domain? Well, I have a fraction, so I know the bottom can't be 0. And I also have a square root, so I know the stuff underneath that can't be negative. So basically, I'm just like, hey, well, x plus 2, the stuff under the square root, that has to be greater than or equal to 0, right? Well, almost. It can't be 0, because the square root of 0 is 0, 1 divided by 0 I can't do. So I just say, hey, that has to be positive only, not greater than or equal to 0, just greater than 0. Subtract 2, boom, x has to be greater than negative 2. That's the domain of that thing. If you graphed it, I'm sure it's going to start with an open circle somewhere at negative 2, and it's going to go to the right forever. Don't know what it'll look like, but I know it's not going to have anything over here, because anything smaller than that will get a negative, and if it is negative 2, we'll get 0 underneath. It doesn't work. So that's it. So here's your homework. What is a function? In your own words. 1.1, numbers 33 through 38. That's the one where you're just matching the graphs to the equation. 1.3, those four are just plugging in numbers for x, doing like f of 5, stuff like that. And then 1.3, those numbers are just finding the domain. So I will talk about those on Monday. Have a good weekend.